Yeah, so let's look for the next sum, right? A ray of light is incident on the surface of a glass plate of thickness t. If the angle of incidence theta is small, the emerging ray would be displaced sideways by an amount given mu g equal to n. So the options are given. So first I have to determine what type of sum is it. I will go for looking at my solution now, right? A ray of light is incident on the surface of a glass plate of thickness. Let us take a glass plate, right? This is a glass plate, and a ray of light is incident on this. A ray of light incidents on the glass plate of this glass plate is of thickness t. If the angle of incidence is theta, this angle of incidence is theta, right? The emerging ray would be displaced sideways by an amount how much? So what is the emerging ray? That I should understand first. If a ray pass through this, because of the glass slab at this interface, it gets refracted, right? So it gets refracted, and then again at this normal, so what happens, this ray again it gets refracted through this face, right? This ray you call it as emergent ray. This ray you call it as emergent ray. This ray you call it as incident ray, and this ray you call it as refracted ray. Refracted ray, right? What is the question then? Ray of light is incident on a surface of glass plate of thickness t, and if the angle of incidence theta is small, which means the angle of incidence, right? So sine I, angle of incidence sine I, this I is approximately equal to theta, which means I is approximately equal to theta, which means very small. The emerging ray would be displaced sidewards by an amount. Emerging ray, how much it has displaced? For this displaced, you should understand this emergent ray is parallel to the incident ray. This emergent ray is parallel to the incident ray. So we have to find out how much it is displaced in the sidewards. How much it is displaced in the sidewards, then this is lateral displacement. This distance x, you call it as the lateral displacement, and the lateral displacement you want to study out equal to how much, that is x. So if you want to find out this lateral displacement, what is x is equal to how much, that is the distance from the emergent and the incident ray, and the incident ray. If there is no the refracting surface, if this interface, this ray would have, because it is little slightly, it is little bent, but actually this ray should have gone in this direction, which is without any bending. I draw for your convenience once again, that is, if this is the ray, right? So it should have passed in this direction. Due to refraction, it passes like this, and again this goes parallel to this. Both the rays are parallel. Now I want to find out this shift, that how much it is taking place. This I have to determine. To make out to this derivation, you can go to my lecture classes, where you can see those lectures, right, in video at study HRS. But here I can directly help you out with this formula to find out. If you know this condition, what is this x, you can write the formula x equal to, right, t of sine I 1 minus of cos I divided by root of mu square minus sine square I, right? So this is the formula to calculate your this x, right? Now I should look after my question. A ray of light is incident on surface of glass plate of thickness t. Here in this formula you can find out thickness t is given, right? T is equal to thickness t, and other thing, if the angle of incidence theta is small, which means the angle of incidence I is approximately equal to theta. So what I can write, this sine I is equal to sine theta, which is again this is equal to theta, right? Okay, and the imaginary would be displaced sideways by an amount, and mu g is given as n, and my mu g, the refractive index, is given as n, and the other terms here, cos I, that is my cos theta, which I can equate it to 1 of small angle, and the rest of the thing, formula mu square, I have mu is equal to n, and what is sine square I? Sine square I, it is, you no need to consider it because of the higher power, so I am neglecting the values of sine square I, because of this I is very small. So now substituting these values, so x equal to, what is my t of sine theta, I equal to theta, so I can make it as 1, that is of sine, it is simply 1, and 1 minus 1 cos I 1 divided by this mu square sine square I, this term I am neglecting, this term, and mu square and the square root of mu square gets cancelled, and only remaining is mu, and instead of this mu I can write this n, mu equal to n, 1 minus n. Alright, so here I have this sine I can take this theta, right, sine theta. So what is my x equal to t theta, 1 minus 1 by n, so I can write x equal to t theta n minus 1 by n. So can you find anywhere this formula there in the options given? So t theta n by n plus 1, right? So you can look here, right, t theta n minus 1 by n. So the option B is the right answer for your given question. So you can go through it once again. So how this is being made out? So any ray passing through and glass slab gets refracted and form a emergent ray. This emergent ray is parallel to this incident ray, and for finding out the displacement, that how much this emergent ray taken from the incident ray, that x is given as x equal to t sin I 1 minus cos I by root of mu square sin square I. By the given condition of 1, that sin theta, that angle of incidence I is very small, I can make this equation as simpler as that. So I is approximately equal to theta, and sin theta is equal to theta. I can put instead of sin I as theta, and cos theta I can take it as smaller, and it is again 1, and sin square theta, because of again smaller, I can neglect this square term, and the remaining is my mu square. So substituting this value, I get x equal to t theta n minus 1 by n, which is your answer for the above question. So you can expect this type of questions in your examinations, right? So you can go with your formula and simplify it based upon the inputs given in the sum after understanding the concepts, right?